Welcome to the build video for my corrugated plastic combat wing. As you can see, I'm going to start off with a little bit of footage of it flying. This is the one I built for myself. I built 3 of these wings. It's fairly easy to launch. Under the default power system, I launch it at almost full power. Flies very nice and stable. It's got good slow flight characteristics. It's fairly good at loops and rolls and acrobatics, as it should be for a combat wing. I put together 2 different configurations for power systems on it. If you're a real serious flyer already, I would consider going for the more powerful system. I built the 3 that I built with the lesser system. It's less expensive and it's a nice system for a trainer. Here's the other 2 wings that I built, blue and red. I tried to do them light on the top with some white and dark on the bottom with some black. You can see in the front of this red wing, there's a front plate, and in the blue wing, a corrugated plastic plate, so it's 2 layers thick in the front. And there's the bottom of the 2 wings with the black and blue. So for this build video, I've sped it up 7 times, so I'll try and talk through it as fast as I can. I'm also including the diagrams with the dimensions in the build video for the main deck, for the stabilizers, and for the front second plate. So on this wing, you can see near the top of it where I've got, oh, that just went by too fast. Okay, here's the parts list for the default parts list, and here's the parts list for the more advanced parts list. I'll go through those a little bit more later. So here I am, starting out. Got the dimensions. I drew the dimensions up first, and drawing them out on the piece of corrugated plastic. I make sure that the corrugation lines are going side to side so that the wing won't have too much flex, too much bow flex on it. And I also add a couple pieces of fiberglass rod across to make sure it doesn't have too much flex. The vertical stabilizers make sure it doesn't have too much flex in the other direction. So I'm just here quickly. This is sped up 7 times, as I said. The entire build took me a little bit over an hour, between an hour and an hour and a half. So this sped up build video will take 10 minutes. So these are all just measurements according to the diagrams that I put earlier, and I'll put at the end of the video again. This wing is a center pusher. It has, let's see, 10 inches of sweep or 13 inches of sweep. I can't remember. I'll have to look at the diagrams again. I think it's 13 inches of sweep and then 10 inches to the back of the elevons, 2-inch elevons. And the pusher, I believe, is 8 inches back from the nose. I've left a 2-inch cavity for the pusher. That's a little bit more than any prop you'll ever need, but it also gives me a little bit of room to adjust the motor frontwards or backwards if needed. I found the CG pretty good at this location. CG typically on this wing would be a little bit in front of where the prop is, but I found it balances really nicely with a 1300 and a 2200 milliamp hour battery, with just some minor trim adjustments. So here I'm just doing the elevons. There's nothing really special about the way I do this, any different than any of the other builds I've done. Cut at a 45-degree angle there. One thing I did find in this build, I tried to maintain the integrity of the top piece of the corrugated plastic. For my other 2 builds, I found it easier just to cut straight through and then do your 45-degree angle and then tape them on. So you'll see that I do a lot of fumbling around in this video trying to get the elevons correct. When building the other 2 planes, I didn't bother with this. It's just too much time without any gain. I found when I left the layer of plastic on the top, there was just a little bit too much resistance, so I didn't like that. So you can see here, I eventually ended up severing them anyway and taping them on just with packing tape. You'll notice the slit between the elevons on this one is smaller than what the diagram was. I ended up widening it a bit, and that was so that to accommodate a rear-facing camera in between the 2. The method for attaching these with packing tape is pretty standard for my foam wings as well. Lots of my other build videos show that. So once those are done, I should be measuring, there we go, I'm going to cut out my vertical stabilizers. Now the total wing size is 30 inches wide and 23 inches deep. I ended up buying a 4x8 sheet of corrugated plastic. I believe it's 4 millimeters thick or so, from Home Depot. I think it was $22. That should be enough to make 6 of these wings. If you've had an election in your area recently, you might be able to find some signs from the election to use instead. If you're going to paint it anyway, it really doesn't matter, and save some landfill. So I cut these off, and I do notches in the body and then notches in the vertical stabilizers, and I found that a pretty decent way to, first of all, get them in so that they're perpendicular to the plane, and second, to keep them in place. Now for this build, I ended up using hot glue for everything, and it sticks fairly well to the corrugated plastic, but I think there are probably things that'll work better. I've seen online some people use CA. I'd also like to experiment with goop, marine goop, and see how that works. Any of the damage that I've had a couple mishaps with it, and they're just because it's so much fun to fly that I've been flying a little faster than I normally would, and a little more reckless than I normally would. But a little hot glue at the field would put these back together in a few seconds, but I have a feeling that if I used a different glue, maybe it would just stay together. There hasn't been any damage at all to the corrugated plastic. So here I'm actually creating one of the second wings. I'm just using the first one as a template, drawing it out on another piece of the corrugated plastic, just so that I have it and I don't have to do my measurements from scratch again. And I did this because I knew I'd be making 3 of these. I planned to do a little bit of combat flying that I didn't actually get a chance to do, but you did see that I got to build the other 2 wings. So I think if you're going to build more than one of these, this probably isn't a bad idea. So back to the main one, I'm about to mount the motor mount. I use my standard piece of angled metal that I buy from Home Depot for about 75 cents. And I mounted my 2822 Emax motor on it. It's a 1200 kV motor. You see me mounting here with a 7x5 prop. When I did my initial tests and I revved it up, it just didn't seem to have enough thrust, so I ended up putting a 9x, I think it's a 9x5 or 9x4 prop on it, and it flies quite well with that. So I stick down the motor mount. I use double-sided carpet tape, and then over and above that I put a strip of white duct tape just to hold it down. So far I've been out flying this maybe 4 or 5 times, and in that time I've had a few hard landings and a few, I guess, crashes, and the motor mount's still on there nice and steady, so that I think that's a good technique for mounting the motor mount on this, and it's nice and easy to do. So here you see me mounting the vertical stabilizers. I'm just doing a dry fit at first, widening the holes where I need to, and just trimming up so it'll work. And there we go, there's some hot glue, and the first vertical stabilizer is in. And let's just play around with the second one, make sure it's all good. Dry fit. And there's the hot glue. And it's as easy as that. The second vertical stabilizer is in place. Now, I should have probably put something at 90 degrees to keep these up. They stayed pretty good on their own. On the other 2 ones I built, I made sure that they had a little bit of support so they didn't end up leaning while the hot glue was drying. So it looks like I'm going to put the spars in. There's 2 spars I put in this. They're shown on the diagram, the instructions. One spar is behind, about a couple inches behind where the prop opening is, and the second spar is directly in front of the prop opening, basically underneath where the motor mount is. And I just used fiberglass spars and polyurethane glue because it'll expand inside and give it a little bit more rigidity. So as I slide the spar into the corrugated plastic, I just dabble a little polyurethane glue on its way in. I don't, when I did the second and third planes, I didn't do the entire spar at the same time with glue like I did on this one. So here I'm doing a little reinforcement in the front. This is different than what I did on the blue and red ones that you saw, and actually ultimately different than what I did on this. So I've replaced this idea with a full front piece that that goes right on the nose, and I have instructions for cutting that piece out. And what I did on the blue and red ones, which are the newer ones, is I also ran that so the corrugation is going perpendicular to the corrugation on the wing, and then ran a fiberglass spar through that and through another piece that's on the other side of the opening for the prop. So to give it a little bit of rigidity in the front. You can see how it'll be rigid behind that front piece because of the vertical stabilizers. But in the front it needed a little bit of extra rigidity. So I'm not quite sure what I'm doing off camera here. Excuse me. Probably preparing for the servos. Oh, there we go, the control surfaces. So I'm putting in, I just use standard control horns. I use my regular technique. I don't use the bottoms of the control horns. I just push them up through the corrugated plastic and a little bit of hot glue on them to keep them in place. These control horns, they could be gift cards if you wanted, or store-bought control horns. I had some store-bought ones, so I just use those. For control rods, I use my regular survey flags and my Z-bend tool. And here I'm setting up my servos. On this build, I used some HXT 900 servos, 9-gram servos. I would recommend going for a Metal Gear servo that's a little bit stronger if you're going to actually use this as a combat plane. If you're going to be trying to run into each other, you're going to hit the ground, you're going to hit each other, and eventually you're going to strip these plastic servos. There's no guarantee you're not going to wreck a Metal Gear servo either, but it might last a little longer. You spend more time flying, less time building. That said, these servos are only $3 a piece, so it's not the end of the world if you do break one. I'm just using my servo tester to make sure that, first of all, the servo works, and make sure that the control surfaces are nice and level when I attach the servos. I attach the servos to the corrugated plastic using double-sided carpet tape, and then a bead of hot glue around the outside to hold them in place. Now I'm looking for some more wires. You see how far back I mounted the servos? That was a mistake. I should have mounted them with longer control arms and mounted them further forward compared to the front of the plane. And that would have allowed me just to use the servo wires as they were and not have to put these extension wires that I'm having to put on now, which make the plane a little bit more ugly, requires some extra tape and hot glue and weight. So that was a bit of a mistake, but I decided rather than moving the servos just to use 2 extension wires. There we are, we're back. Okay, I'm just adjusting the location for the receiver. The receiver's on there. The ESC is on there. The ESC is a 15 amp Hobby King ESC, which is fine for the 2822 motor. If you go for the faster edition, that's where most of the expense is going to come in. I recommended a Turnigy Plush 40 amp ESC, and that comes in at $20 compared to about $7 for this ESC. And that's another reason I went for the less expensive option, because I was building 3 of these. They still fly fine with the lower power. The one difference is it's not quite as easy just to take off vertically from a stall. And in combat, you may want to be able to do that. Of course, the faster you go, the faster you're going to hit the ground. So this, at this point, with the exception of that this doesn't have the front piece on that I end up using ultimately. There we go, me switching props after doing the thrust test. And now I'm just using GWS, I think 9-inch prop. So now this is me attempting to waterproof some components by spraying them down. Not quite sure what I'm doing there, but I'm plugging all my components in, making sure my directions are correct. Yep, we've got everything looking good. All set up on the transmitter. One thing to note, the way I mounted these servos on here is opposite to most of my other wings, so I had to set up a new model type in my transmitter. How you mount those servos is up to you on yours, but on my other two that I built, I mounted them in the same directions as my other wings, so that they would go with the people's controllers that were going to get them. I attempted to waterproof some of the components for this plane, and that was a little bit of a mistake. You can see me spraying right now with plastic dip, and it just ended up making a big mess. I still might end up doing that for a plane to fly in the winter in the snow, but the way I did this, I like the plastic dip better, that you actually physically dip the components in and then let them hang to dry rather than this spray. The spray just reminded me of undercoating for a car or something. Just ended up making a mess, and I don't really think it added a whole lot of waterproofing to what I have. So here, Stacy and I were out this morning in a little bit of a windy morning. You can see how overcast it is, and she took some pictures of me flying. I've got some video as well that I'll end up editing, but I just thought I'd include a couple of the pictures of it in the air in its final painted form. Decided to go for black and yellow bottom and yellow and white top, and that seems to be working fairly well. Even at a distance I can tell top from bottom. The one thing I did is I only painted the outsides of the fins. I probably should have painted the inside as well. Would have made it a little bit easier to see in certain configurations. That's a nice shot, I like that one. So it's a very nice flyer in low wind and no wind. I also flew it in high wind, and it flew, but everything's a challenge to fly when there's lots of wind. So I was able to go vertical with it, not for an unlimited amount of time, but I was able to hang it vertically, almost in a 3D kind of nature. That was sort of fun. Just play around with a bunch of loops and rolls and low passes. It's definitely one of my most fun planes to fly. There's me looking like a cyborg. Okay, so we're on to onto the build instructions, and these are just basically the directions, the dimensions you're going to need to build this. 30 inches wide, 23 total long, 13 inches from nose to of sweep, and then another 10 inches to the back of the elevons, each elevon 14. Well, yeah, there you go. I'm not going to go through all the dimensions. You can read them off of here. Hopefully I've made them fairly easy to make out, and it's a very, very simple build. And as far as fun for your build dollar and fun for your time spent building and durability, it's an excellent plane. The one thing for this plane that I would advise is it is made of corrugated plastic instead of foam. It's going to do more damage if it hits something or somebody, so fly it in an open area. Of course, the idea of doing more damage is great if you're hitting other planes in combat. And here's the parts list for my less expensive build. You can see $16 in parts. That doesn't include battery or receiver. And then I'll pop up the more expensive parts list. And this one would be able to go unlimited vertical and would be extremely fast. It's a 2826 motor and a 40 amp ESC, metal gear servos, so a little more durable, and of course the control horns don't really matter. Again, this doesn't have a receiver or battery in it. So that's it. I hope you enjoyed the build. Thanks for watching.